Hello and welcome back. Alright, in this video we're going to go ahead and write a object-oriented version of our linked list. So, in order to get started, I'm going to need to add a couple files. So I'm going to go ahead and right-click on Source, click Add, New File, C++ over here on the template side, and create a new C++ file, and then click Next. Okay, so I'm going to call my file name. We will call it linked_list. And I will happily have a new .h file created for me. Thank you. And we'll click Finish. Okay, so I get the nice little standard copyright block. Let's go ahead and delete that. And our header file, now let's go over and look at our CPP file and delete it out of there too. Okay, so you can see that our CPP file is empty other than including our linked list header, and our linked list header file is completely empty. So let's go ahead and add our include guards. So we'll do pound if and def linked list underbar h underbar, oops, pound define linked list underbar h pound and if. Okay, you can capitalize these, lowercase them, whatever. I'm just going to lowercase them here because it was easier to type in. Okay, so the first thing that we're going to need is we're going to need to create a new class definition. So we type in class linked, linked list. There we go. We have defined a new linked list. Okay, so if we remember back from our other videos, we had a couple methods that we're going to need to write. So I'm going to create a public scope, and we will have, we needed an insert method which added something to the beginning. So I'm going to call this push front. And we don't actually need to pass in the linked list pointer because the linked list is the object that we're already working on. So we already have a pointer to the linked list because instead of having our data and our functions disjoint and separated, they're together in one place. So we just do int val. So this is my header file, so I'm just defining the function prototypes, the member function prototypes. Alright, so we have push front, which is going to add it to the beginning of the list. We'll have void push back int val, which will add it to the end of the list. And then we will have a void delete and int val and a void print. Okay, so those were our four basic methods we had. Now, if we also remember, we had these initialization and deletion or cleanup functions. So what I'm going to do is I'm going to create another public section just to separate these out because they are special functions, and I just want to note that in this video. Typically, you'll put them all in one section, but for this purpose, I just want to really call these methods out. So in C++, there are these things called destructors and constructors. Constructor is called whenever you create a instance of a new class. So either on the stack when you define the variable, or on the heap when you call a new keyword with a class type. The constructor method is called. And the way you define a constructor is simply the name of the class and parentheses. Notice that there is no return type, and that in this constructor there are no parameters. This is called a default constructor. So I'll just write that over here. This is a default constructor. You'll also see constructor written as ctor. Okay, now for a cleanup method, the destructor gets called whenever a instance of a class goes out of scope, or when the delete keyword is called on a pointer to a class type. And the way you define it is with a tilde and the name of the class. And there's, again, no return type, and all destructors are parameterless. They take no parameters. If you try to assign a parameter value in here, you'll get a compile error. And so the tilde key, if you're not familiar with that key, it's the shift backtick on most keyboards. It's to the left of your 1 key. Okay. Now, that about wraps up the definition for linked list. So let's go ahead and copy and paste all of our function definitions and jump over into our code file. Paste them in and delete the publics, because those do not get transferred over. I'm going to delete this comment as well. Okay, so now we have told the compiler that in our header file we have this class definition. Now in this CPP file, what we are literally doing right now are defining completely brand new functions. We are defining some global functions to this file. And that's not what we want to do. What we actually want to do are define the functions that we defined here, or declare the functions that we defined here. And the way in which we do that is we scope the functions. And so you put the class name and you use the scope operator, which is 2 colons, to associate the function or the member that you're accessing as belonging to the class that you've defined it. So in our list.h file, we have this linked list, and we have this function, this constructor right here. Well, in order for the compiler to know that in our CPP file, that this linked list function is indeed the same linked list function that I'm talking about here, we need to scope it in. And that's what this is doing. And so we need to do this for all of our member functions. And this goes as a prefix to the name of the function. So it does not go before the return type of a function. It is considered as part of the name. Okay, so we've scoped in all of our functions. Now let's give an empty body to all of them. Get rid of the semicolons. And now at this point, I can actually build my function. And we are actually getting a funny Objective-C error here, it looks like. Okay, so let's go ahead and rename our delete to remove for now. And rebuild. Okay. Okay, so we have our linked list. Oh, our delete was a keyword. Can't use that. Okay, so we change our function to remove. Okay, so now if we think back to what our linked list initialization function did, well, it checked to see if the list that we were being passed in during the initialization was null, which we don't have to do. And the next thing it did is it set the first pointer to the node as null. Well, we don't actually have that yet. So let's go ahead and jump over to our header file. So you can see that we are missing our node definition. And now there's a couple ways that we could do this. What I'm going to do is we can go ahead and define a struct, and we can call this node and put it up here. Well, as we learned in our other video, A struct is nothing more than a class with a default public field. So, I mean, we could change that. But what I'm actually going to do is I'm going to do this thing called a nested class. And so what that means is that you can actually define a class within a class. And I don't want that to be too confusing, but the reason I want to do that is that I actually want to associate that node as belonging to this linked list. So I can go ahead and cut this out and plop this in right there. And that's perfectly legal and legit code. Now, remember our node took an int value and a node star next. We can build. You can see that it is indeed happy. Well, great. So I'm going to create a private field. And remember, now we need that head pointer. Well, that head pointer is of type node. Build. The type is looked up, which is this type. So now when you access this, if we think about our scope operators that we just talked about over here, well, the scope of this type is linked list node. We don't need to reference it that way because of the scope that we're in, but if we were needing to, that's how you would reference it. Okay, so let's go back over to our CPP file and our initialization. So you notice that, or remember back from our initialization code, we need to set our head pointer to null. I'm just going to use 0. If I were to actually use null, let me show you the error that you're going to get. You're going to get null was not declared in this scope. And the reason for that is that that's the actual proper error that you should get in this case. And that's because we haven't imported or included any of the header files that actually define the null macro. So instead, I'm just going to use 0. And 0 is just as fine to use null. Some people like null better because it semantically ties in a pointer. But 0 is just as legitimate. And in C++, 0 and null are treated exactly the same. Okay, so we're going to set our head pointer to 0. And we can rebuild to clear out that error. All is happy. Okay, so now if we think about our destructor, what we did was walk the list. And so if we I'm actually going to bring up our previous file. Linked lists, this one. Okay, so this is actually our previous code. And let's look at our cleanup. So what our cleanup did is we checked to the list null. The list was null. And the next thing that we did was we walked the entire list. Well, we can copy and paste this code over. So let's go over to linked list now and copy and paste that in. So we're going to have to change our code a little bit. Instead of a capital N for node, I'm going to have a lowercase here, lowercase node there. Now instead of doing list arrow head, all we need to do is head. And the rest of this code is exactly the same. So we should be able to build here. Oh, sorry, that null should be 0. Now we can build, and all is good. All right, let's go grab our push front code, which is our insert code in our linked list definition. Okay. So let's go ahead and copy and paste all of this. Jump over to our linked list CPP file. Push front. Okay, so we don't need this first line because we already know that we're dealing with a valid list. We can get rid of all of the list arrows. We can change null to 0. New node is a lowercase node. Node here, lowercase. and value, and next. Get rid of the list arrow, and get rid of that list arrow. Now, if we still wanted to actually reference the pointer for the class that we have, there's actually a special pointer called the this pointer. And the this pointer is an implicit pointer that you get for all classes. And what that does is it points to the location in memory of the instance of the particular instance that you're working with. This is totally not necessary in most cases, so I'm just going to leave it out. Okay, so we have push front. Now what we need to do is go grab the push back implementation, which is the list push is what we have there. So I'm just going to copy and paste this back in here. Change our nulls to 0. Change our nodes to lowercase n. And I just did it lowercase n's this time just to keep in style with the STL libraries. If you don't know what the STL libraries are, they are the standard template libraries. Yeah, the naming convention is really up to you though. So I went through and deleted all the list arrows from here in this code. Okay. So here's our pushback code. Again, it's basically identical. And now let's jump over and grab our delete code. Okay, so our delete actually belongs in our in our remove function. Okay, so copy and paste that in. We do not need the list is null check. We do, however, need the head pointer check. And if that equals 0, go ahead and return. We change our node to point to the head. Okay, special case on our first value. Get rid of that list arrow. Perfect. Lowercase that node. Get rid of the null, replace it with 0. Everything in there is fine. Everything there is fine. And then we can build. And then we'll get a failure. Oh, so in our node definition in our other linked list, we called it value. So let's go ahead and call it value again. Okay, perfect. So now the only function left is the print function. So let's go ahead and go grab that. Alrighty, here is our print. We'll skip out on the list equals null check, not needed. Jump down here, print. We'll do node next is head. Get rid of the null and replace it with 0. And you notice when we build, we'll get some compile errors. Oh, that's because we need to bring in the IOStream libraries so that we can get access to cout. So we'll just go ahead and put it up at the top here. Include arrows, IOStream, and rebuild. All is happy. Okay, so we've now object-oriented our linked list. So let's go ahead and look at our old code. And let's go ahead and replace all of this code right here in our old main with the object-oriented version. So let's come over into main CPP. Now we're going to need to include that linked list because we actually want to use it. Okay. Let's paste that code in that we had before. So instead of list here, we're going to have a linked list. Instead of the init, we're not going to we're just going to delete that because the constructor is going to get called for us. Instead of list push, what we do is we do list, and in order to call or to access one of our members, we do the exact same thing we did when we were dealing with destruct. We use the dot operator. And now instead of getting data from a member field, we can call a function just like we normally call the function. And so we have push front, and we do not need to pass in a reference to list, but instead we just pass in the value. So I'm going to go ahead and copy and paste this. Oh, I'm sorry. Push is actually push back. Okay. Copy and paste that. We will overwrite all of our pushes with pushback. We will delete the address to our list. Okay. And now we want to call print, so it's just list.print. No parameters because the address to a list is not required as it's already known. Now we wish to delete something, so we do list.remove. The value is 2. Then we want to print it, so let's just copy and paste that. We'll replace all the prints here with that call. The remove will go here, and we're removing 1. And I changed this in another spot to make sure that my code actually worked correctly. So that should actually be a remove 3. And we'll get rid of that delete. Okay, so we have now replaced all of our deletes with removes and just passing in the value that we care about. And now list.insert should be list.pushFront. We'll copy and paste that, replace those, and we will fix print method, get rid of all of the lists. And we're going to get rid of the cleanup because the destructor is actually going to get called when this main function goes out of scope. So it might look like, hey, we're getting a memory leak, but we're not because we actually handle that in our constructor or our destructor. So if I build this, see our build succeeded. Bring up the output window and run it, and you'll see that we got the exact same output that we got before. Our list contains the values 1, 2, and 3. Then we deleted the 2 and we're left with 1 and 3. Deleted the 1, we're left with 3. Deleted the 3, we are left with nothing. And then we inserted 1, inserted 2, and pushed to the front 3. So when we print them, we get them in the reverse order. And really, that was it. And our code looks a little cleaner. Our functions are all wrapped up into this list object now. So instead of calling a function and passing in a pointer to some data somewhere, all of that is all wrapped up into one. And so we've got to use some header files here. We've got to see how we scoped in. Remember to scope in your functions. This is the biggest thing that people forget to do when they go to implement the body of their functions. They forget to scope them in. But yeah, so we got to clean up our code. We got rid of a little bit of code. This is actually going to be less error prone because there's no chance of passing in null pointers and forgetting to do that null pointer check. Yeah, so with that, I'm going to call this video good. Thanks.